Okay, one of the reasons we use two's complement for representing negative numbers is because it lets us build subtraction into the process. And so to illustrate this, I think it's best to start with decimal. Okay, so the equivalent of two's complement in decimal would be ten's complement. All right, so to get the tens complement, what you do is you take the nines complement, okay, to get the nines complement, any number that you have, like let's look at 318. Uh, for 318, you take the first digit 3 and you do 9 minus 3. Okay, so 9 minus 3 is 6. All right, so we have the first element of the first element of the nines complement. Okay, then the 1, so 9 minus 1 is 8. All right, so we write that down. And then finally, 8, 9 minus 8 is 1. So the 9's complement of 318 is 681. So from there, you add 1 to get the 10's complement. All right, so let's think about how that worked. The reason you get the 9's complement is because essentially what you're doing is you're taking 999 and subtracting 318. So that's why you do 9 minus on all those digits. So you see right there is where subtraction is built in. 999 minus 318, we have the subtraction built in. We're subtracting essentially 999, all right? So the trick is when you add 1, 999 plus 1 is 1,000. Okay, so essentially when we do this, we're getting an extra 1,000 showing up in the calculation. And so at the end, we end up subtracting that back off. Okay, so let me show you how that works with the formula. A minus B is the same thing as A plus 1,000 minus B. So I added an extra 1,000 in there. Okay. So to get to the extra 1,000, I can take the 9's complement, because 9's complement is 999. Okay. And then you add 1. So this would be 1,000 minus B instead of 999 minus B. All right, so think that through. It's a little confusing the way I said it, but you essentially have you've built in an extra 1,000 into the calculation. The subtraction shows up right here, 1,000 minus B. And so the nice thing about 9's complement is you know that you'll never have to borrow. Okay, 999 minus any number, you never have to borrow. Okay, so it's built in to that calculation. Okay, so from there, we now have the number that we're subtracting. So we're taking 725 and we're subtracting 318. So that's the next step. 725, and then we add the 10's complement. Okay, so when we add the 10's complement, 5 plus 2 is 7, 2 plus 8 is 0, carry the 1, and then we get 14. Okay, so this extra 1, that's the extra 1,000 that's built into the calculation. And we just ignore that because we discard that 1 because we know that it's built in. And that gives me the number 407. Okay, so we know if you did this the other way, where you just do regular subtraction with the borrowing, you get the same result. Okay, so let's go through one more calculation. You can change this and play with these numbers yourself. So 421. Okay, what is the 9's complement? 9 minus 4, I've got to calculate. 9 minus 4 is 5. 9 minus 2 is 7. 9 minus 1 is 8. Then we add 1, we get 579. Add these numbers together. This is what you get. Discard the 1,000, you get 304. So you see, it's built into the process. You know, the 9's complement business builds the subtraction in. And so with a 10's complement representation, you can actually do subtraction with an adder circuit where you never have to borrow. That's the point.